Boa tarde a todos e todas. Hello, everyone. Today we have the great pleasure to receive for our seminar Anna Wiedemann, Dr. Anna. And thank you, Dr. Anna, to accept our invitation for this seminar. It's a great pleasure to have you join us today. And let me introduce you for our public. Dr. Anna Wiedemann is the co-head of the research group IS Strategy and Management at the Zurich University of Applied Sciences. She earned her PhD from the Technical University of Munich in Germany. And Dr. Anna currently research focuses on Agile IT, DevOps teams, and qualitative research methods. She has successfully disseminated her research findings through publications in journals such as the European Journal of the Information Systems, Information and Organization, Communications of the Association for Computing Machineries, and the various referred conference proceedings. Her work has been featured include the International Conference on Information Systems and the European Conference on Information System. Thank you again to join us, Dr. Anna, and the floor is yours.
Thank you very much for the invitation. I'm very happy that I'm allowed to speak today. So let me share my screen. Okay, it's loading.
Okay.
Perfect. So today I'd like to present a short introduction about my research with the title Achieving Product Orientation in DevOps Teams. I will start with a short introduction about the motivation of the topic. Then I'd like to present 2 insights about my recent publications. And I would be very happy then to discuss my findings, my insights with you later. So if you have no other questions, I would like to begin with the presentation. So as you may know, agile software development methods have become very popular, and in a lot of areas they are now the status quo, how to develop business-critical softwares. However, as the name already indicates, agile software development methods are mainly used by software developers in the IT functions. Organizations want to be better in collaborations between software development, but also with software operations departments. So they aim to solve bugs fixer and earlier. And of course, they want to achieve a better collaboration between these 2 units. So if we look into current IS information systems literature and also into practice literature, we see that these 2 departments, development and operations, have very opposing goals. So for example, software development focus on speed. On the other hand, software operations focus on stability of a running software, which is leading to tensions. So organizations on the one hand want to implement cross-functional teams to provide faster software features for their clients. But on the other hand, it's very likely that tensions will appear if these 2 different units have to collaborate together. So for effectively managing tensions, research and practice needs further understanding how to achieve that. And if we look into information systems research, we see that control and alignment theory could help to explain these different aims and scopes to manage project teams. However, also in information systems, there is a huge focus on software development projects, and little is known about IT operations. And especially if organizations want to combine software development and software operations. So I linked my recent publication, which is explaining a control approach for DevOps teams, but I'm also presenting it now in this presentation. But before I go into my research, I'd like to give you some introduction about what is DevOps and what are the benefits about DevOps. So why should companies integrate DevOps teams into their IT functions? So companies that are not working with DevOps, we see that 56% have release cycles for business critical applications of 1 to 6 months. That means for implementing a new software features, companies that are working with waterfall methods or sometimes also agile methods needs 1 to 6 months to implement these new features for the end customer. So the customers have to wait a very long time. On the other hand, you may know that it is not very comfortable if a software bug appears, and sometimes even the complete software is down and you cannot work. And recent studies show that employees lose 2 weeks of working time due to IT outages on a yearly basis. So this is causing a lot of costs and frustration for IT employees and also for organizations. However, if you look at companies that have successfully implemented DevOps teams, we see that they are able to provide 208 times faster code deployments into production environments. Furthermore, they have a 7 times lower downtime. So the risk that they will have an IT outage is much lower. However, if it comes to an IT outage, these IT functions are able to faster recovery their IT systems, namely 2,604 times faster. So what is DevOps and how has it developed? So in the last century, most of the IT projects were managed with the help of sequential procedures, such as waterfall development methods. So if a new software was developed, the project used long phases for planning what the software can do at the end. Then it moved to requirements engineering, development, test, and so on. And as these little steps indicate, it was very hard to go back to earlier phases because it was simply not planned to go back to earlier phases. So to achieve more flexibility, IT functions realized that they have to become agile. In 2001, the Agile Manifest appeared with several guidelines how IT project could be managed in an agile way. So that means that now software development and also the business side is moving way closer together. Yeah, that, for example, the business customers can now mention if they have new priorities, and now the planning process can be adapted. And also the software development team could now show what they have developed in the last 2 to 4 weeks. So the procedure becomes way more iterative. So that was very, very helpful to achieve a way better collaboration with the software, between software development and the business departments. However, it was still a big issue to implement and deploy new software code into a production system, because till today, a lot of IT projects using agile methods only in test environments. This is the fact because IT operation is typically not involved into an agile way of working. So that's why 2009, the buzzword DevOps appears. So it's an abbreviation of software development and operations. And Patrick Dubois made this term popular. So DevOps means that we go beyond agile software development and implement IT operation in the agile way of working. So in my research, I define DevOps as a cultural and technological concept for integrating the different skills and tasks related to software product planning, development, and operations. Typically, a DevOps works very well in cross-functional teams, and they focus in general on one product. So the development and operation of one software-based product. So if you compare DevOps to Agile, this classic framework is missing. So if you work with Scrum, you have a very detailed description which roles and responsibilities should be involved into that process, which meeting structure is helpful, how a sprint is conducted. But if companies want to implement DevOps, they could use these key principles, which became very, very popular. And organizations who want to implement DevOps should consider these CALMS principles. So CALMS, this is not a typo, it stands for culture, automation, lean, metrics, and sharing. So culture is defined as the culture of working in so-called DevOps teams. So there's a huge transition if development and IT operations teams have now worked together. So in the past, they had really different ways of working, and I will talk about that issue later. And now they have to improve this culture of learning and collaboration so that they achieve a very, very successful environment. Then a very obvious principle of DevOps is automation. So in DevOps teams, manual work should be avoided, and tasks from development and also operations should be automated. So even in the agile world, automation was already a big part. So for example, continuous integration and delivery was already used in the past in IT development. However, today we see new concepts and methods like AI ops or machine learning ops, which also helps to automate a lot of manual tasks and operations. So here, the DevOps teams could be relieved if manual work is automated. Then, as most of the agile methods, the lean principles are very important for DevOps work. So lean means that processes are getting as lean as possible. So lean went popular in Japan. Yeah, you may be familiar with the famous Toyota case, where the big automotive company achieved leanness in their supply chain management and their logistics. But you can also use these lean principles in software development and operations, because also these processes can be structured very lean, and also the backlogs, so the amount of work for these DevOps teams, could be organized in a very lean way. Then we see the M, which stands for metrics. It is very important that DevOps teams measure their success, or even also failures. So especially in IT operations, we can measure a lot of different metrics such as response times, resolution times. But also in development, there's the option to measure deployment times and other metrics, which could be helpful to show the success of DevOps teams in the IT function. And the S stands for sharing. So the S of CALMS. So sharing is caring also in DevOps teams. So sharing knowledge is very, very important in DevOps, because now people are not working in their traditional department structures. They are now working in teams, which means the amount of people is really reduced in these teams. And now they have to share the knowledge, because sometimes you have to stand in for each other because people are sick or on leave. And now it is important that the people have enough backups in their teams. So sharing is also a very important principle. So now I explained a lot of different methods and concepts from practice. I'd like to introduce you my research now. So in the past until today, my research is focused on alignment and also control theory. So I investigate DevOps management principles on the one hand from alignment. So alignment is defined as the degree to which the needs, requirements, goals, and structures of one component matches the needs, requirement, goals, and structures of another component. And if we look at DevOps, we see that there's an internal misalignment between these different tasks and departments. So typically they have very different goals and structures, how they work in their daily business. On the other hand, control is defined as the attempt to align individual behavior with the goals of the organization. So alignment or align is part of the control definitions. So we first have to understand how this internal IT misalignment can be solved, that as in the next step, we find out how DevOps teams can be successfully controlled, that the organizational goals and aims can be achieved. That's why we put forth the following research questions. So first, we identified the mechanisms by which software development and operations achieve alignment. And on the other side, after we identified these mechanisms, we were interested in what control mechanisms can successfully navigate the tensions in DevOps teams. So I'd like to start with the operational alignment in DevOps teams. So I had a look in prior information systems literature, and then it became very, very obvious that there's an internal IT misalignment between software development and software operations. So for explaining this problem, we used the very famous model from Henderson and Venkatraman, the IT business alignment model. And here you can see a very simplified representation of that model. And we were especially interested in the operational alignment, so the green boxes. So how can organizations achieve alignment between business and IT from a process and infrastructure perspective? And if operational alignment is achieved, then also strategic alignment can be achieved and conducted. But then we found that DevOps mainly appears here in the intra-IT box. So the processes and infrastructures and skills between software development and software operations are very different. So, for example, if we focus on the different goals of software development and operations, we see that developers want to achieve very fast new software deployments in a running software. On the other hand, we see software operations, which is focusing on stable running systems. So that means every time when a new software deployment is conducted, software operations is afraid that the system is not working well then again. So every change can lead to a problem. The next topic we identified in IAS literature are processes. So on the one hand, we see that software development focus very much on project methods like agile, software development, waterfall development. So it's very process oriented. On the other hand, we see software operations focusing on best practice approaches. So in IT operations, for their daily business, they use concepts or best practice approaches such as ITIL, IT Infrastructure Library, for managing their daily business, such as incident and problem management. There's really clear guidelines. The next point was competencies. So software developers typically very, very much innovation oriented. They want to work with new tools, new technologies, want to be always up to date so very, very proactive. On the other hand, software operations is very problem solving oriented, so very reactive. If a problem appears, they start working. And of course, they want to avoid that new technologies and tools are implemented in the company because this could cause more work for them. And the fourth topic we saw in IS literature is the interoperability. So development teams used to work in agile team setting or in project settings, and software operations is focusing on different areas. So for example, they have support centers and they are focusing on a lot of different software products, for example. So in sum, we see a lot of issues for misalignment between development and operations. And now we conducted a multiple case study and investigated several DevOps teams. And we wanted to find out how this misalignment could be solved. And therefore, we derived the so-called tripartite intra-IT alignment model. So this was an inductive study with the help of grounded theory. And in our qualitative study, we found these 3 green boxes, namely integrated responsibility, individual componentization, and multidisciplinary knowledge. So these 3 mechanisms helps to produce intra-IT alignment. So for example, DevOps teams should use integrated responsibility. So for example, they should integrate the agile way of working in development and operations. So a DevOps team should conduct a daily meeting where the people and the team members introduce their issues, their workload, and so on. But not only the development side should present, also the IT operations people. They should also present their workload and the issues, and they should also put it into the backlog if something appears which need consideration. The second mechanism is focusing on the more infrastructure-oriented components of DevOps teams, so the individual componentization. So DevOps teams are able to conduct silent releases. That means no more downtime is needed if they want to do a software deployment. That means the deployments are so small now that they can be implemented into a running software without a downtime. This is a huge difference. If you look into the past, IT operations members had to spend a lot of time on the weekend for implementing huge software releases. And now we see alignment here between development and operations because they're working now very close together and conduct so-called smaller and silent releases. And multidisciplinary knowledge is the third mechanisms we derived. Here we see, for example, the problem ownership. So DevOps teams are responsible for in general for one software product. So in the past, IT operations people were responsible for a lot of different software products. And now this is changing because the knowledge is restricted to this one software product, and now development and operations could learn a lot about this single software product and enhance their knowledge and skills in this area. So this was our first study regarding IT intra-alignment. So with the help of these 3 mechanisms, we achieved alignment in this area. So now we knew the alignment mechanisms. Now it's important to understand how control is enacted in DevOps teams. So therefore, also here we went into the information systems literature. And as I already mentioned at the beginning, there is a huge amount of excellent literature in the area of software development. And control is defined as a management attempt to ensure that individuals working on organizational projects act accordingly to the strategy and achieve desired objectives of the organization. And Kirsch, 1996, presented 4 different control themes, which seem to be really applicable for our DevOps study. So the 4 control themes are control effects. So control effects focus on the project performance, and control effects typically focus on quality and efficiency of IT projects. Then the second theme in software development is control choices. So here we focus on the antecedents of our project control portfolio. So these antecedents are typically based on control modes and the control amount. So control modes could be, for example, input control or output control. So some projects have unlimited budget and time for producing something. Then it's sometimes not necessary to control the input. But maybe it's important to control the output because you want to achieve something really special with this project. On the other hand, which is more common, that you have to control the input. So you have to control the time and the budget. So this is a classic input control mode. And there are several more control modes which need consideration if you have a project. Then the third theme is control context. So control context refers to the project size, the tasks, and the relationships between the controller and the controllee. And the last topic is control dynamics. So these concentrates on how the control modes and amounts are changing over time and are really exercised in practice. So we used these 4 themes for our research and went into existing literature. And we found that control effects, choices, context, and dynamics are very different in development and operations. So for example, control effects in development focus on efficiency and quality of the project outcome. So typically, software developers are very outcome oriented. They want to achieve a very, very good software product in time and budget. On the other hand, the control effects in operations, so they are measured in general by service level agreements, so-called SLAs. So how many tickets have they solved? How fast? How was the resolution time? So the measurement here is really, really different. Then we see the control choices in software development. So we have this classic control modes that I mentioned a minute ago. So there are formal and informal control modes, and the degree and control choices are very, very different in development. IT operations focus on standardized operations processes such as COBIT and ITIL to manage and control their daily business. They want to avoid software outages and they monitor their systems with the help of different tools. Then we see control context also differs between development and operations. On the one hand, development is focused very much on projects. I already mentioned that, agile, waterfall. On the other hand, IT operations is very end user oriented. So if the end user has a problem, this is the main context of IT operations. And lastly, control dynamics. Here we see that in software development, there are a lot of dynamics. So software faces changes a lot during this project lifecycle. On the other hand, IT operations has very less changes, only in terms of implementing new technology and platform changes or implementing a new cloud platform. this would cause a lot of dynamics in IT operations, but typically not in their daily business. So we compared these different control themes in development and operations and found 4 tensions that could appear between software development and operations. So the first tension is the goal conflict that I mentioned because of the speed and stability issue. The second tension is this method discomfort. So on the one hand, developers are used to agile methods. On the other hand, IT operations focus on structure, very structured approaches with ITIL. The third tension is this decision right tension. So IT development focuses or is managed by project managers with very dedicated time and budget orientation. On the other hand, service managers are typically responsible for managing operations work. And these 2 management styles are very different. Yeah, the one are more innovative, the others are more reactive and problem-solving oriented. So this is causing problems if they have to make decisions together in DevOps teams. And the time rhythm stress was the last tension we identified. So developers are typically very short-term oriented. They want to focus on their sprints and provide new prototypes, for example. On the other hand, IT operations don't want to have a lot of changes. They want to have long-term stability and orientation. So now we were interested in how we can navigate through these tensions. And therefore, again, I'm a qualitative researcher. We conducted a qualitative study, and for deriving our results, we started to code along our a priori defined tensions. So we asked our interview partners, what are they doing to achieve control or to have a good controlled team. And we wanted to find out how this goal conflict, method discomfort, decision right tightness, and this time rhythm stress is solved. So in our first level coding, so if you conduct qualitative research, you have to start with a very open coding approach. So which is basically the transcripts. So you code basically the transcripts from your interviews. And we coded along these a priori defined tensions and how these tensions were addressed. And then in this second order concepts, I hope you can read it. It's a bit small, sorry for that. So the second order concepts are like a summary of our first order concepts to bring it to a higher level. And then we have this aggregated dimensions, which say how our different tensions are solved. So this is the Gioia method. So if you're interested in inductive qualitative research, I can highly recommend this paper. And this is giving you a lot of guidelines how to achieve this coding approach. So we have these 3 aggregated dimensions, namely participation in shared vision, right of co-determination, and common sense of duty. And as you could saw in this coding picture, these different dimensions are addressing our a priori defined tensions. And as you saw also in our coding approach, these second order concepts are our key mechanisms and explanations how these tensions are now solved. So for example, a goal conflict can be solved with the help of consensus or automation. So since DevOps teams are now working toward one software product, they achieve a common goal regarding this product. So they're getting a lot of coaching how they can develop this software product, and they build consensus around this product. And now this is solving this goal conflict. So participation in shared vision is defined as that development teams develop and act a common view of a collaborative working style. The second aggregated dimension we derived is the right of co-determination, whereas DevOps teams have now the responsibility to have joint decision rights, and they focus on the software delivery lifecycle, on this one product. So if a problem appears, for example, they are now responsible for managing the problem together. So there's no more finger pointing in this time. And the third aggregated dimension is the common sense of duty. So here DevOps teams achieve like an ownership, and the controller, so the person who is controlling the DevOps teams, has to adapt the leadership style, because DevOps teams do not need this classic command and control leadership style. Because of the product orientation, which is implemented in this DevOps team, they need more like a transformational service-oriented leadership style. So these different approaches, like our key mechanisms, our tensions, and our aggregated dimensions, are depicted in this model. So here you can see a summary, which key mechanisms are addressing which tension. So mentality change and responsibility acceptance is addressing decision rights. And the aggregated dimensions help us to explain how these tensions were solved. So to summarize our findings, of course, we provide some implications for research and practice. I will keep that short. So in sum, my research found that it is very important to extend this agile way of working towards software operations. So software operations should now become a key issue in the dailies. People should be involved, present their work amounts, their problems, and also visualization of software operations work is very important. So the DevOps team should not only put development work on their Kanban board, they should also put software operations work on the Kanban board. We saw eye-opening situations where software operations people addressed that a lot of users called regarding a bug, and software developers and also the product owner thought that this software bug is not a big deal. It could wait several sprints to get solved. But now, since the software operations part is part of a team, it can have eye-opening situations where really people realize how important it is to have this perspective and also now the end user view in the DevOps team. Then from a control point of view, it's important to have more freedom in the DevOps team and less central control. As I just mentioned, we see that it is helpful to move away from that command and control approach toward a transformational leadership approach, where these cross-functional teams are coached and empowered to have this product orientation and this product responsibility, because developers and also operations people are not used to work in this new team approaches and to have so much responsibility. This is something new, and the people need coaching because they cannot do that from day one. Then the third implication is the transformation toward product orientation. So this classic IS literature focus very much on projects. So project orientation with budget and time restrictions and so on. But the DevOps team is very much oriented toward a software delivery lifecycle. So the team starts working when the software was born, and if the software is shut down, people stop working. So there is a constant further development of the software product, and you cannot plan that very well from the beginning. So you may not have this time restrictions and budget restrictions like in classic agile or waterfall oriented projects. And further research is needed here, how product management and product orientation can be managed and acted. And the use of modular IT architecture is very helpful, that DevOps team can work and can collaborate if several DevOps teams are working together. So a modular architecture and containerization was also a main finding of my research. So further research topics could be in the area of data ops and AI ops. So how these topics can influence the work in DevOps teams, but also how IT operations is developing now, because I think this is causing a lot of change here. Then, of course, I have to mention AI because it's everywhere. So how can cross-functional teams, for example, DevOps teams, can apply AI in their daily business? Then we see the application of low-code and no-code platforms. This could be very interesting from the point of view that software operations people do not always have development skills and programming skills. So this could help a lot in the collaboration between development and operations, because now also operations people can use no-code platforms and develop products. Then I see several call for papers focusing on IT identity. So how, for example, the individual role is changing. So as I mentioned before, IT operations people have to adapt a lot in their role, and from an IT identity theory perspective, this could be interesting to investigate. And I think what it is missing currently is like a practice guide for DevOps implementation. So this is more practice-oriented study, because we don't have this strict guidelines how to implement DevOps in an incumbent company. So maybe there's a need for a step-by-step introduction how companies can implement DevOps. So we need, for example, roles, meeting structures, like we see in Scrum, but I think practice is missing that a little bit. So that was a very short introduction about some of my research topics, and I'm very much interested in your feedback, in your questions, and I hope to collaborate in the future.
Thank you very much for this amazing presentation, Anna.
Thank you.
And we are waiting for your questions from the audience. Please don't be shy to ask. If you need, you can ask me in Portuguese, and I will try to translate to Dr. Anna. Let me remove your slides here. You mentioned about artificial intelligence, and sorry for the biased question, but as I am a researcher in artificial intelligence, because we are hearing a lot about AI versus DevOps, and about the use of generative AI in DevOps. And do you think we can take advantage of AI? These teams can take advantage of AI, and could you mention for our students and the computer science professionals that are freaking out and worried about to be replaced by artificial intelligence? Could you mention something about this, please?
So, yeah, it's more like a personal opinion, because I'm searching for master theses in that area. So for students who want to write about that. So I see that AI could be very helpful in supporting the work of DevOps teams, not replacing. It's like every technology innovation we see in the past, and also we see 100 years ago, it is just beneficial for us using this technology. Yeah, and if we think it's not helpful, we should not use it. But now, I see it in both areas, for software development and software operations. So software developers could fix their bugs with the help of AI and be faster in this bug fixing area, because this is sometimes for a lot of developers a little bit of an annoying work. Some really enjoy searching for the bug, but some just want to fix it and work on new features. On the other hand, in operations, we see that this AI ops is becoming really a big topic. So incident management and problem management there could be a revolution there. And also there for problem analysis, it could be really helpful. And I'm a service manager. I was a service manager before I went back to academia. And I know how hard it can be to search for the needle and to find where the problem was really caused. So I think this would be, for me, it would be great to have AI in operations.
Thank you. But do you think what we can see if we don't have an expert team, we can put weakness on the softwares coming from these generative AI codes, and the importance of our expert teams in software development to overcome and to not put this weakness inside the softwares. Do you agree?
Yes, absolutely. You have to be careful in using this, and not only in every area we are using that, not only in development or operations, because for example, ChatGPT is very easy to get wrong informations and that you easily adapt that. And I see this with my students, if they copy paste information from ChatGPT which are not true, or that they are working with wrong references, for example, which is sad. So a machine can only be as good as the person who has developed it. And we need the experts who are developing this technology. We should use it, but we should always be very careful. And there should always be a step back and decide and think about if this is really helpful or if it's causing more problems.
Okay. The audience is thanking you for this seminar. But we don't have questions. Maybe they are shy about to ask today. But
maybe you can ask in Portuguese, or you write me an email. That's no problem. Or add me on LinkedIn. Happy to answer.
Okay. Thank you again, Dr. Anna, for this amazing seminar. And again, the audience can ask by email or send me. I will send for Dr. Anna your questions. And thanks a lot to be with us today. And tchau, pessoal.
Tchau. Bom dia. Thank you so much.